All right, so this lesson we're going to talk about random numbers and use random numbers in order to answer a question. So maybe we have a question like the one that's in one of the board sheets where we suppose we have a 20-sided die. You're playing a game where you have to beat a 10, 11, 12, 13, 14, and so on and so forth, right? So what we're saying is like if there's an established number like 15, how many die rolls would you need in order to maybe get a 50% chance of doing better? In other words, is this a game that you are willing to play in the long run? What we're going to do is use this idea of sort of random numbers and creating maybe a simulation to gain experience using a simulation instead of actually doing it, right? So one option is to basically get out a die and set the point and then give yourself 2 rolls and then see if you can beat it with how often out of the maybe 1,000 times that you perform this experiment, how many times out of 1,000 that you would beat 15. And then give yourself 3 rolls and say, well, how many times given 3 rolls would I beat a 15? And when I say beat, I mean score, roll a number on a 20-sided die that's larger than whatever the set number is, right? So that's the idea. I want to know this answer, and then we're going to create. Hopefully, at the end, we'll create a graph in the very end. Before we do anything, I want to sort of abstract the idea of a die, right? So a 6-sided die anyway, kind of looks like this, where we have a 1, and when you roll it, and this is the thing that's face up, then you'd get a 1. If you roll it, you get this. We would call that a 2, and it's just the number of little dots that appear on the die. What we're talking about is this idea of a 20-sided die. So it kind of looks like this thing. I forget what geometric thing this is called, but it has 20 sides on it from one numbered from 1 to 20, and you can roll it and so on and so forth, just like you do a 6-sided die. Okay, well, with that being said, how do we sort of abstract the idea of a die? I don't know. I mean, this is sort of my interpretation of what a die should be. It should have sides, all of the sides from 1 to however many sides that we have, numbered, all the sides numbered. I guess I should put the word number there from 1 to num sides. You should have a face up. So these are the attributes right here, right? So face up, I should have the number associated with the current number that's face up. So for example, face up would be 20, and then sides would be 1, 2, 3, 4, 5, all the way to 20 for this die. For this one, I don't know how many sides. It looks like there's 8 or so. This would have numbers 1 through 8, and the face-up side in this particular case would be 8. And maybe this one has 1 through 4, and as you can see, the number 4 is face-up. Okay, so this is what we want to build first, and this video is just totally concentrating on building that, and then we'll come back and worry about answering the question. So let's pull up a Jupyter Notebook. And now, before we start anything, I'm going to import NumPy as NP. I'm going to, even though we're not using it right now, I'm going to import matplotlib .pyplot as PLT. Shift enter, and then we'll get down here. So we're going to build this class called a die. It's an object. And then whenever you initialize it, the constructor method here, we're going to pass in, obviously, self for every one of them, but I'm going to pass in the number of sides we have. So that's all you need to do in order to create a new object that's of class die. So we'll use self.sides. I think that's what we used. I mean, it doesn't matter if you use these attributes, sides and face up. I think I'm going to put an underscore on up. I don't know. But self.sides would be equal to np. So if I'm going to use the arrange function in np, obviously there's lots of ways we could do this. I'm going to go from 1 to num sides, and I believe you got to put a +1 here. And then unfortunately, I shouldn't say unfortunately, because it's probably you need most of the time you need floats here. But in this case, we want these all to be integers. And then I'm going to use and maybe we've seen this before. Yeah, I think we have seen this one before. We're going to use the random.shuffle command. And what the random shuffle command is, you pass in a list or a NumPy array and it will shuffle those suckers up for you. So sides and then self dot face. So what are we going to do? I'm going to let self dot face equal to self dot instead of face up. Okay, that's what we're going to do. Instead of face up, I'm just going to call it face. I don't know why I said up. I mean, the face of the die. I guess there's N faces on the die, but I'm going to call face up just face. And then so then I'm going to go into this self dot sides, and because it was shuffled, I can just get out the one on top, and that's what we'll call it. We'll call the 0th one, or the one in the top of the queue, or top of the list, or the NumPy array. We'll let that be our face up side. All right, and let's enter. Let's call this 20. Let's call it die. Oh, put in 20. Enter, and then 20 dot face. So let's see what that is, and it's 10. So if you called it again, shift enter, it'd be a different number. Shift enter 2, right? So it's just letting you know where it sits. Now, if I can't do print, obviously you guys remember, if I try to do just like print 20, or if I just 20, hopefully it gives us this object basically, or if I told it to print 20, it should give us the same thing, right? It's just trying to string that the thing that just came out there. So if I wanted to tell us some information when I hit print, or when I hit just shift enter, then I got to pass in self. And then what do we want to come up? The question is, what do you want it to print out to the screen? I don't know. We just print self.face. I think that's enough. Or maybe we do str. The str self.face would be a number, and maybe we want it to be a string. And then underscore repr. So our representation, we could just call. I think if you don't do anything, it'll just actually if you don't do anything, it'll probably still give you that main.die. We'll return self.face. We'll return a number this time. Self.face would be a number, and then def roll. So what does a roll look like? So if I tell it to roll. Basically, we wanted to do the same thing that we did up here and return the top one, right? So I'm going to copy this, Control C, Control V, and then we want to return which would be self.face. Roll is the name of the method. But what we're doing is we're shuffling the sides again, and then getting the one off the top, and then returning that. Shift enter. So now if we print 20, or if you do 20, shift enter. Ooh, it didn't like that. It said that the non-string. Oh, maybe I do str as well. Did not like that. Shift enter. Okay, so now it's giving us the 12 and the 12. All righty, let's see. Oh, let's test out the roll. So 20 dot roll. And so this is not, if this were an attribute, right? So let me try this again. 20. I just want to make sure that we're feeling comfortable with this dot face, right? That's going to give us dot face. Now, why didn't I put the parentheses on here? Because that's not a method, right? So this is going to say, hey man, you can't call that. You're a knucklehead for trying it. Face is an attribute for this class die, which means it's a piece of data. It's not a method. It's not a function. If we call a function that doesn't have anything in there except for self, then what we want to do is put parentheses on there. In other words, there is no input for this thing, but you're acknowledging the fact that it is a method. All right, and shift enter. So if you try to do it without the parentheses, it's going to say, hey man, I mean that's a function, you know, it's bound and blah blah blah. So this is basically telling you it's some kind of function, but it's not going to do anything for you. So you got to put those in. So you can just keep hitting this and get different rolls. And so these are where the random numbers pieces are coming from. This np.shuffle is producing the random numbers that we're interested in. Okay, that's really all I have for this video. I hope you guys got something out of it, and we will use this class in starting it. So I'm going to keep this in the next video, and then we're just going to kind of keep going and try to answer the question that we posed at the beginning. See you next time.